So when we are using the mean and we're doing a test, a mean, if you recall from previous chapters, you use the normal model for the mean when you know sigma. So that is if sigma is known, the population standard deviation is known. So these steps, these first steps, this is review. We've done all this before. Nothing is new on that except identifying that significance level. You can use the table in Appendix B to find the z-scores, or you can use your calculator using the inverse norm feature. But what's new is finding that p-value and deciding whether you reject or fail to reject. So all of this is the new part. You make a decision about the null hypothesis and alternate hypothesis and decide whether you reject or fail to reject. So let's do that with this example. In auto racing, a pit stop is where a racing vehicle stops for new tires, fuel, repairs, and other mechanical adjustments. The efficiency of a pit crew that makes these adjustments can affect the outcome of a race. If they're really efficient and they get the car running in a record amount of time, then that can make the difference between winning a race and not winning a race. So one pit crew claims that the mean pit stop time for 4 new tires and fuel is less than 13 seconds. A random sample of 32 pit stop times has a sample mean of 12.9 seconds. We're supposed to assume the population standard deviation is 0.19 seconds. Is there enough evidence to support the claim using an alpha level of 0.01? Okay, so let's extract the information that we can from this. We know that n equals 32. We know that the population standard deviation is 0.19. We know that the mean pit stop time that we're trying to compare things to is 13 seconds. We know that for our sample, it came up as 12.9. And we know our alpha level is 0.01. First, we need to come up with our claim. So our H naught and our H alternative. We want to decide whether we can support this claim. So the claim is that the mean temperature or the mean time in the pit stop is less than 13 seconds. That means that the H naught is greater than or equal to 13 seconds, meaning that that's the normal for cars. In order to use the normal model, we have to make sure that we're using a random sample and that our n has to be greater than or equal to 30, which it is. So we're okay to proceed. We checked our conditions. We need to find our z-score, which takes the sample time, 12.9, and subtracts the mean, which is 13, and divides it by the standard deviation. But we have to find the standard error that's going to go in there. So the standard error is going to be equal to the population standard deviation, which is 0.19, divided by the square root of n, which is 32. And that comes out to be 0.19 divided by the square root of 32. 0.0335875,721. Then we're going to put that right there. 0.03357 and all those decimals. So 12.9 minus 13 divided by that is going to be negative 2.977297171. That's our z-score that supports our picture. So our picture, because of this, is a left-tailed normal model. That means this z is equal to negative 2.9773. So to find the p-value, we're going to do normal CDF of negative 200 to negative 2.9773. And that's going to give us 0.0014541048. That's our p-value. Now, in order to decide whether we reject or fail to reject, we have to look at our alpha. Our alpha is 0.01. Our p-value is 0.0015. That means our p is certainly less than our alpha. So in our final statement, with a p-value of 0.0015 and an alpha of 0.01, we reject the null hypothesis. There is enough evidence to support that this pit crew has a pit stop time of less than 13 seconds. That's the conclusion that you have to make sure you include when you are doing problems like this. Now you can do this on your calculator also. So the calculator steps. First you go hit the stat button. And then once you hit the stat button, you move over to tests. And then under tests, you're looking for the z-test. For all means where you're dealing with large samples where you know the population standard deviation, you use a z-test. And once you're in a z-test, you have a choice between data and stats. You're going to use stats because that's what you know is the statistics. And your mu naught is going to be what's in your null hypothesis, which is 13 seconds. Your population standard deviation is going to be the 0.19, which they gave you. The sample mean is going to be the 12.9, the mean pit stop time for those samples, and your n is going to be 32. And the next part you have to make sure is you have to decide between not equal to mu naught, less than mu naught, or greater than mu naught. And this is a left-tailed test, so you have to use left-tailed. And that's going to give you exactly the same p-value.